it's 100 square meters, but they're going to be exceeding the local zoning requirements by 25%, as in where they're supposed to be providing 100 square meter, they're providing 125 square. In this case, what is it going to impact, right? So the first is A, community connectivity, B, quantity of rainwater available for irrigation, C, size of the LEED boundary, D, size of the area to plant native vegetation. Anybody can answer. Okay, so the fourth question, just let me know what your answer is, just to see if you're going in the right direction or not. We're trying to score ourselves, we're trying to evaluate ourselves just to see how much we've actually understood from the class. Okay, and in case there's something that's missing, it is a good way to recap. It is a good way to check how far we've come. Okay, I'm just going to go ahead and give you the answer to this. So in this case, increasing the open space would actually not help in community connectivity, right? Because connectivity refers to, trying to provide areas for community gatherings or trying to help people come together, which is not really happening just by introducing an open space. If that open space is purposed for something, purposed for congregation or celebration spaces, etc., or recreational activities, then it makes sense. So community connectivity is not directly impacted. The second, quantity of rainwater available for irrigation, right? So quantity of rainwater would increase. Okay, you can gather more rainwater if there's open space. You can allow more water to percolate inside. But for irrigation, that again is not really a direct impact. The irrigation, purposing that particular water that is gathered from that open space would actually depend on the project team or the owner of the project. Right? The third, size of the LEED boundary is not impacted by the open space. So the answer is actually D again. Okay, size of the area to plant native vegetation. Over here, what you're trying to do is you're trying to restore the habitat. I remember mentioning this one point when we were looking at what all can be done on site, right? So these are additional credits. You're trying to restore the natural habitat. You're trying to increase the area of any vegetation. Over here, putting a native vegetation would contribute towards the restoring habitat credit. And you're providing habitat for the wildlife, as in the flora and fauna. You're also promoting stormwater, control. You're allowing water to percolate inside. You're indirectly reducing the urban heat island effect. Okay, so all of this can be done when the open spaces increase. So the answer for this would also be B. What does the use of light-colored pervious paving help with? This is the fifth question. We have to answer 2 for this. So what is the use of light-colored pervious paving help with? A, regional materials, B, heat island effect, C, recycling, and D, stormwater management. Okay, so I can see an A and D in the answer. D is right. You are helping in the stormwater management. Okay, but it would not be A, it would actually be B. Why? Because light-colored materials are not really, something that's only found in your particular region, right? Okay, when I say regional material, I'm looking at context. I'm looking at easily available materials in the locality, easily available materials within a set radius of that particular project. So anything that can be sourced locally would be a regional material. That does not, is not helped by using light-colored pervious paving. The heat island effect, however, would actually be helped by light-colored pervious paving. Why? The pervious paving allows the stormwater to seep in. That's how the stormwater is managed. The light color over there Okay, that is where the heat gain coefficient we were talking about, right? All of the heat gain elements would actually be reduced, and automatically we saw certain uh, images explaining this about how light colored materials are actually better than dark colored materials. It is the same logic that we have of why we wear light colored clothes in summers and darker color clothes in winters, because uh, black attracts or dark colors attract more heat, right? So using a light color over there would actually reduce the amount of heat. So the heat island automatically reduces when you use a light color. So the correct answer would actually be B and D. Okay, you have to get both of this right. So in LEED, when you have this type of questions where you have to choose multiple answers, getting one of them wrong would also not earn you the point. You'll actually have to get both of them right for you to get the question right. All right. So read it again. Actually, this one was a very straightforward question. All that we've done until now, all the 5 questions that we've come across till now, are straightforward questions that we've seen in the class. This should not be too much of a problem. Question number 6, a project team has decided to shrink the building footprint. This change can have a positive impact on what project area? A, pedestrian access, B, open space, C, parking capacity, and D, carpool parking. B, open space, right. So when you're reducing the building footprint, you're allowing more place for the open spaces, more area for landscaping, for green areas. Okay, so you're allowing more vegetation to come in, you're allowing more perviousness and porosity to come in into your site, right? So this again is very straightforward question. Sometimes we also have to take this into it's just a point that's coming to my head. So in urban areas, you don't really have open pockets as such. You don't have areas for that allow the fabric to breathe. So in such cases, even green roofs are considered to be open spaces, vegetative green roofs. Over here, yeah, this is again a direct question. I think you got it right. It's a very easy one. So what is the building footprint? Question number 7. Area of the building structure only, B, building structure and hardscapes, C, entire project boundary, and D, building structure and landscapes. Right, okay, so I can see an A, area of the building structure only. Yes, again, this is a very direct question. It's there in the reference guides, and it was there in the slides too. So area of the building structure alone, that it is the building footprint. Okay, building structure and hardscapes, the option B would actually be development footprint. And entire project boundary and building structure and landscapes, these are not the building footprint. So question number 8, what is albedo? A measure of plant's drought tolerance. B, measure of a material's imperviousness. C, measure of a material's ability to reflect sunlight on a scale of 0 to 1. D, measure of a refrigerant's ozone depletion potential, ODP. Right. So it is the albedo is the solar reflectance, right? So it is the material's ability to reflect sunlight, and it is measured from a scale of 0 to 1. As in the black objects are 0, the light colored or white objects are 1. When you have a figure of 1, as in when it is a complete white object, it is considered to be 1, and that means it is reflecting of all the light that is incident on it. So total reflectivity state is represented by 1, and albedo, the other term for albedo is solar reflectance. Now, question number 9, what are the attributes of open space? Here again, you have to choose 2. A, open space has been previously developed. B, open space is shaded. C, open space is pervious. D, open space is 100 feet beyond the building perimeter. E, open space is vegetated. This is again a straightforward question. I think you can get the answer. Anybody can try and answer this question. Right. So C and E is the right answer for this. Open space is anything that is vegetated, anything that is pervious. None of the other three options actually, define an open space. So the attributes are quite clear for this. Question number 10. What information is needed to determine if a product will help with the heat island effect of a non-roof surface? A. Emissivity of a material. B. SRI of the material. C. Life cycle costs of the material. D. Runoff coefficients for the material. Right. So SRI, which is the solar reflective index. Okay, it talks about the amount of solar heat that is rejected. Okay, and reflectivity emittance combined would actually give you this SRI. And again, this is on a scale of 0 to 100. 0 is the black surface. 100 is a white surface, which is mostly reflective by nature. Okay, and anything that has a high SRI value are actually cooler, and they are a better choice for paving and for roofing material, right? Say for example, black asphalt actually has an SRI of 0, right? So over here, when you look at the heat island effect, you're going to be looking at how much heat is trapped in the atmosphere, right? So how much of heat gets reflected off a material would actually contribute to this information. So emissivity of a material is also under the SRI of the material. So we're looking at reflectance and emissivity when you look at SRI, which is why that is the better answer over here. Moving on to question 11. Right. What would not qualify as a previously developed site? A lot where there used to be a road. B. Greenfield lot donated to the city. C. Good evening, madam. Could you also please share the question on the screen? Right. Okay. Just a second. Right. Okay. So you can see it, right? Please let me know if it is visible for you. I'll continue from where I left off. Okay, it is visible. All right. So we were on question number 11. Right. So we've finished question 10. You're right. Okay. So what would not qualify as a previously developed site? A lot where there used to be a road, a greenfield lot donated to the city, a lot reseeded with native grasses, and D, a lot that was recently graded. Right. So the answer is very straightforward. Anything that's developed is not a greenfield, right? So anything that's a greenfield is not developed. Automatically, the B is the right answer. Greenfield is anything that's undeveloped, anything that has been natural. Again, I think we had a very similar question before. So we saw a very similar question in the first one. Which site could be considered a greenfield? Over here, the answer was 5 acres of farmland that was plowed to grow corn, right? So again, over here, we looked at a farmland in question number 11. It's a very similar question. Over here, it's the greenfield that is donated to the city. Now, question number 12, which of the following statements are true? A, using regional materials will help with construction waste management. B, installing salvaged bicycle racks will help with community connectivity. C, using reflective materials on parking areas will help reduce the heat island effect. D, installing salvaged windows will help save energy. C, using reflective materials on parking areas will help reduce the heat island effect. That is the right answer. We saw the explanation for this in the previous questions also, so I'm not going to repeat it. 13th one, what is not an example of smart growth? A, development of a site that is far from existing development and infrastructure. B, neighborhood design that has offices and shops within walking distance to public transportation. C, retail, office, and residential townhouses on the site of a former gas station. D, a residential development on a previously developed site located near shops and schools. Right, I can see an A, development of a site that is far from existing development and infrastructure. Of course, that's not an example of smart growth, right? So smart growth is basically where you develop near transportation areas, where you develop where there's already housing or residential areas, where there's jobs that can support the economy. So you're basically staying away from all the green fields, you're staying away from all the open spaces and farmlands, and you're not developing them, right? So all of this are examples of smart growth. The B, C, and D are examples of smart growth, and A is not an example. So question number 14, what information is needed to calculate the SRI of a material? So this is a direct formula application. You have to choose two: A, emissivity; B, thickness of the material; C, reflectance; and D, thermal gradient. A and C, right? Emissivity and reflectance is required. Again, we discussed this. All of this, if you see the pattern of questions that come from this particular chapter that we did are very repetitive by nature. The basic logic of the chapter is constant, and all they're doing is actually twisting the questions here and there to see if you've understood the concept thoroughly. Okay. Question number 15: a site is described as a site described as accessible means the site meets the requirement of which standard? A, AIA; B, USGBC; C, GBCI; D, ADA. Right, okay, somebody's actually got D. This was something that we did not discuss during the class, okay? But it's additional information. So anything that is accessible. Over here, we're not just talking about how do you access the site, but we're trying to make it accessible for all types of user groups. So there are different kinds of people that come onto a particular project. You have people, you have kids, you have youth, you have people of the working class, you have people who are actually senior citizens coming in, and there are people with differently abled groups that come in, right? So making a site accessible to all of them is what they're trying to do over here. And for this, the ADA, which is actually Americans with Disabilities Act. So this particular act, you know, lays out the standards or guidelines for accessible design. So this was an additional information. It's good that you got it right. USGBC and GBCI do not really classify a site as accessible. It has to be done by the ADA. Now, question number 16. What is the benefit of increasing the quantity of open space on a project? Again, it's the same question that we have again. I'm guessing you all would know the answer to this. It's B, reducing the heat island effect, right? So anytime you open up more, anytime you have more open space on a project, you're going to have more area for vegetation, you're going to allow more percolation, a lot of water goes into stormwater is managed, etc. So reducing the heat island effect is the direct benefit that we get for reducing the development footprint and for increasing open space. Now, question number 17. What refers to the relationship between the total building floor area and land area and the allowable land area the building can cover? A, community connectivity, B, site area, C, floor area ratio, D, development footprint. Okay, I can see a C, right? So the answer is floor area ratio. This is actually a definition by USGBC. Community connectivity, site area, development footprint. You're actually aware of all of this, right? You're aware of all of the definitions for A, B, and D. And when we're talking about the total building floor area and the allowable land area that the building can cover, which is the building footprint, that is the floor area ratio. FAR is the short form for it, which we use in common terms. Okay. Now, question number 18. Which of the following do not contribute to increasing the heat island effect in urban areas? Okay, so we're looking at what does not contribute to heat island effect. A, vehicle exhaust. B, absorption of heat by hardscapes and its radiation to surrounding areas. C, open grip pavement. And D, bioretention points. Now, you have to choose two for this. Okay, yes. So thank you, Chris. Thank you, Aaron. The answer is C and D, open grip pavement and bioretention points. So open grip pavement was actually suggested to, allow more porosity in the site, right? So when we were discussing parking spaces and how do you encourage, stormwater management, increase water efficiency, etc., we looked at open grip pavements. And bioretention ponds was also one of the measures that people pick up, or it is one of the measures that people pick up, and we discussed this under, what is when and we're